All right, well, let's go ahead and get started. Thank you all for joining us. In this training, we're going to very quickly cover how to configure our computers to write these software programs. It's very simple. We're going to use both the CLI, which is the command line interface, as well as IDEs, which are integrated development environments, to write, compile, and run our applications. And then we're going to create a Git repository on our computer and push our programs to GitHub. Quick bit about me. My name is Ryan. I'm the co-founder of CodingNomads. I've been a software engineer for over 10 years. I've been teaching software development for over 5 years. And I've been living the digital nomad lifestyle for at least 3 years, and on and off many times before that. So why learn Java? Java is the most in-demand language in the world. There's a fun video online, I think it's called Java Apocalypse, which is kind of like a movie trailer.
We have to leave. They're terminating Java.
And it's like a movie trailer of this apocalyptic scene where they turn off Java.
Whoa, close call. Why the hell do we even have this other button here?
And it's a very apocalyptic scene where planes start falling out of the sky.
Somewhere around.
Electricity grids go down. And it's quite funny, and it's also quite true, because Java is just omnipresent across the software development world. And oftentimes you're using Java when you don't even know it, right? There can be Java in your car, there can be Java in your microwave, there can be Java, there's Java in the Mars rover. Java is just omnipresent across the software development world. And it's also one of the best first languages to learn. And this is because it enforces best practices. It makes it easier to learn other languages, and I'll explain that. And a nice thing about Coding Nomads is that there's very few courses and kind of boot camps out there that teach it. But back to the first point about enforcing best practices, Java is known as a very verbose language, meaning it's very wordy, right? And it's strict. It requires you to write code in a very specific way to satisfy all kinds of requirements and dependencies. Otherwise, it will not compile, it will not run, right? So when you learn Java, you're learning all the little rules and all the little requirements and dependencies that are required to make a nice program run. Whereas with other languages such as Python and several others, they handle a lot of those little rules and requirements under the hood, and they abstract that complexity away from the user or from you. And so one of the nice kind of things about learning Java first is that when you go to learn another language like Python or JavaScript or any of these others, they seem easier, right? You can pick up Python in a week or two, the core language, if you already know Java quite well. Whereas the inverse is not necessarily true. If you know Python quite well, and then you go to learn Java, you're going to have a pretty steep learning curve, and because there's going to be all these new things that you're not used to having to deal with, right? So there's a little bit extra overhead in learning Java first, because it is a little more, let's say, tedious or verbose of a programming language. But it gives you a very good foundation for software development, because you become aware of all these rules and requirements that all software development languages use, but some of them kind of handle it implicitly for you. So it puts you in a nice place to start. Why learn Python? So Python is super hot right now. It's the #1 fastest growing language in terms of the number of people that are using it to code. It's everywhere. You can use it for web development, for data science, for machine learning, and just writing any kind of little script that you can think of. Python is more of a scripty language, right? So whereas Java might be more building kind of like enterprise software applications, Python, you could also just use it for, you can do the same thing with Java, but Python is a little better suited to just write a little script that does this one thing. It pulls data down from some source, analyzes that data, converts it into CSV or an Excel file, and that's all it does. It's just this one little script, right? So Python is a little bit more of like a scripting language, but it can also be used to build large enterprise applications. And it's also generally considered to be the most intuitive server-side programming language. The reason Python has become so popular has been recently. It's almost equally as old as Java is. And again, it's also been updated, and every year or two, there's these big updates to Python that make it a more and more modern language. So even though it is an old language, it's very modern because it's constantly being updated, as is Java. But the reason it's gotten so hot right now is because of all this data science, machine learning, AI kind of stuff. And the reason Python was chosen was that in the beginning, basically with the machine learning data science folks, that all started from mathematicians, right? People who are not necessarily computer scientists, they're mathematicians or statisticians. And they do all of their work in kind of formulaic on paper and or sometimes using the R programming language. But they needed, basically about 15 years ago or something, there was a consensus where a lot of these mathematician style people wanted to start being able to translate their equations, basically, that they had into scalable, viable software applications. And they were looking for the simplest, most robust, most intuitive server-side programming language to use to do that. And that's why they landed on Python. And then over the last 15 years or so, a large community has built up around the data science and machine learning ecosystem in Python, right? So even though you can do, there's really nothing you can't do in Python nothing you can do in Python that you can't do in Java, and vice versa. Literally, you can do the exact same thing with both languages. They just have slightly different best practices and use cases potentially. But the nice thing about Python for data science and machine learning is that there's hundreds and hundreds of packages and libraries out there that have been created for the data science and machine learning community, to help them do particular tasks. So again, so like sending that email so that you don't have to write all the code from scratch. You can basically leverage this code and these packages that other people have already written to make your life a lot easier. And so since AI, data science, and machine learning have been boosting in popularity and interest, it's brought Python along with it, which has been quite interesting. But Python has just had this major, major resurgence in the last few years. It was kind of just a mid-level server-side language that was somewhat popular, but not necessarily hugely popular. And as data science and machine learning have taken off, Python has just started soaring. So Java is still by far the most widely used language, but it's losing market share on a day-by-day basis to Python, which is growing and growing. So let's jump into a little bit of this training here. So what we're going to do is I'm just going to show you what you need to download and install on your computer to get started, right? And so for this training, we're going to be using Java, Python, and Git. And this is all you really need to get started. Obviously, the more you go, there's all these things that you need to install. But to get started with software development in Java or Python, all you need to do is install the Java JDK, which is the Java Development Kit, or the Python interpreter, right? So, we will create a GitHub repository, and I'll share this with you. And in that GitHub repository, I'll have these links. But installing Java and Python and Git are quite simple. So I think what I searched here was just Java JDK, and just go here to Java SE Development Kit. And you go to these downloads, and you just download the installer for your operating system. And then it'll kind of walk you through it. And I'm not going to actually walk through that right now because I've already got these installed on my machine. But just like any other application you install, it's quite simple. You can also download some demos and samples for any system as well. These will just have some practice applications and some other things to kind of get you up off the ground. But for instance, I'm running on a Mac right now, so I would just click this link right here, download the DMG disk image, double click on it. It would step me through the installation, right? What this installation is going to install for me is the Java JRE, which is the Java runtime environment. And the JRE contains the JVM, and the JVM is the Java virtual machine. And the JDK basically gives us the compiler and binaries and all the things that we need to write and compile and run our application. And as a like a quick primer into the JRE, JVM, and JDK, what makes Java so versatile and so popular and powerful and has for many, many years is this idea of the Java virtual machine. And the Java virtual machine, back where it was originally, the reason it was originally invented back in the mid-90s was back then you used to have to write a compiler, and a compiler is basically what takes our more or less human language looking code and turns it into machine code that the computer can actually execute. But back 20 plus years ago, you used to have to write a compiler for each CPU that your application would be running on, right? That was extremely tedious. And also, so they created this Java virtual machine where all you need is a single Java virtual machine for each operating system. So sure, you still have to have, you know, a Linux, Mac, Solaris, Windows version of the JVM, but you just need those 4. And whichever operating system you're running on, if you have that JVM, now you can run Java applications inside that Java virtual machine. It's not really the way most websites are run anymore, but the JVM was also revolutionary for web development because back in the late 90s and early 2000s, most websites that we interacted with were very static, right? They weren't dynamic. There wasn't, you couldn't interact with them. You couldn't play games with them. You know, they were just kind of web pages, static web pages. That's because before the JVM and a lot of more modern recent developments, having code that would actually run on a user's browser was very dangerous because there was no way to safeguard that code from doing malicious stuff, right? So let's say that you go to some website where it has you play some tic-tac-toe game. You're going to be downloading some code from a server that runs in your browser. And before the JVM, there was no way to ensure that that code wouldn't be doing anything malicious. And so the JVM, when it's running on your machine, it'll run all the Java code and it'll basically keep everything in a nice, safe container. So what we need to run Java on our computers is the JDK, which is the Java Development Kit, and that contains the JRE, which is the runtime environment, and the JVM, which is the Java Virtual Machine. So it's a lot of little details there, but one of the things I kind of say here when we're first getting started is it's not necessarily important to know exactly how every piece of an engine works in order to drive a car, right? So it's important to know that you know, the oil, like how to check the oil and brake fluid and a few other things are kind of important, but you don't need to be a mechanic in order to drive a car. And our goal here is to learn how to drive a car, not necessarily be a mechanic. So don't get overwhelmed or overburdened by some of these details, in this case with Java, with the JRE, the JDK, the JVM, etc. Just giving you a little bit of an intro there. For Python, it's quite simple. Again, I just Googled install Python 3, and it's very simple. It's detected the operating system that I'm on, and this will be a disk image as well, or a package. Well, I'll download it, double click it, install it. And the way that we can verify that these things have been installed on our computer once we've gone through that installation process is open up a command line. So I'm on a Mac here, so I use iTerm. There's also terminal, which is kind of the built-in terminal on a Mac. All Linux systems have a built-in terminal, and then Windows has something that's called the command prompt, CMD, where you can run all these commands there. As software developers, we use the command line very, very regularly on a daily basis because it just makes our lives easier. We can do very, very powerful, effective, and efficient activities and commands through the command line. That would be much more tedious and or just kind of headache-inducing if we had to do them kind of using a graphical user interface. But so for Java, the way that you test that it's properly installed is you just type java-version. You can see here that I've got Java 1.8 installed. So now I know that Java is installed. And so for Python, and right now, kind of recently, Python 3 has come out. So if you just install Python and say -- version in this case, here you can see I've got Python 2.7 installed, but you can also say Python 3 because I've installed them both. And here you can see I've got Python 3.6.5. So if I were you getting started right now, I would just go ahead and install Python 3. And I think with this, here's download Python 3.8.0. Python 2 is very widely used out there. That was the primary version that was used for many years. And just now people are starting to shift over to Python 3, which has some added features. The last thing that we're going to want to install on our computers is Git, right? And so Git, and again, I'll share all these links. Here we've got the installation instructions for Linux, Mac, and Windows. And once you've gone through the installation process, again, it's just a download and a double click type of thing, and it'll walk you through the installation. From your command line, you can say git -- version, and you should see something like this. And as soon as you've got these 3 things installed, or whether you're just interested in Java or just interested in Python, you can do one or both or the other, and Git, then we're good to go, right? So now we verified that we've got Java installed, we've got Python installed, and that we've got Git installed. So what I'm going to do here is I'm going to create a folder on my desktop. So I'm going to type pwd to print working directory. I'm currently in my home directory. So I'm going to say cd desktop. So now if I type pwd, I'm on my desktop, and I can create a new directory on my desktop. And I'm going to call this webinar. So now I'm going to cd into my webinar directory. And if I say ls-al, it's empty. And now if I go, for instance, if I say cd .. that'll take me up one directory. I can say open webinar. And this is actually a folder on my, there it is. This is actually a folder on my desktop. And I'm going to put all the code that we write in this webinar in this folder. And I'm going to create a Git repository out of it. And then I'm going to push all that code to GitHub and share it with you all. So I'm going to go back into webinar. And let's do a couple of things here. So I want to start really, really simple with Python. And Python is interesting because it's not a compiled language, it's an interpreted language, right? So it's a little bit different from Java in that instead of having the Java compiler that compiles code into machine code that the JVM then runs on the CPU, Python has an interpreter which interprets the code that we write and then passes that basically down to the CPU. The downside of that is Python is generally known to be significantly slower in execution time than Java, but it has some nice things. For instance, like you can work with Python interactively. So I can just type Python 3 right here, and now I'm in what's called the Python shell. So I can say, for instance, num equal 3, and then I can say print num, and it prints num, right? I'm gonna exit out of this real quick and start from scratch. I can say something like import random, and this is just a package that's part of the Python libraries. And then I'm going to say num equals random.randint, and we'll put, let's say, between 1 and 100. So now if I print num, it's 42, and then I can reset num. So I just say num equals a new randint. If I print it, 91, 20. 62, right? So Python is really nice in a way because you can work with it in this interactive way. This is not really the way that we work with Python usually at a professional level, right? Because we're always writing kind of larger applications. But if you just want to test something, play around with something, demo something, Python's really nice because you can open up the Python shell and just start writing your Python code and run it and like basically verify that it works, right? The other way that we can do it is create a Python script or file. So what I'm going to do here, we're going to create 2 applications for both Python and Java. And we're going to create one for Python and Java in the CLI, and then we're going to create one for Python and Java in IDEs, right? So let's start with a very simple Python application that will check for prime numbers. We'll print out all prime numbers between 1 and 100, right? So what I'm going to do is I'm going to use Vim, which is a text editor for the command line, and I'm just going to say prime.py. So Vim is an application. It's a text editor that you use for the command line. Prime is just the name of the file, and py says that it's a Python file, right? So now I'm in Vim. I'm going to hit the I key to go into insert mode, and now I'm going to just write my application. So I'm going to say for, let's call it num in range, and range is a generator, which basically it'll loop us in this case through every number between 1 and 100. And this is a for loop, which is a definite iteration, it's called. So in Python and Java, we have various types of loops. We've got the for loop, the while loop. The Java, we have the do while loop. And we use them for different purposes. But when we know exactly how many times we want to loop over something, we'll use a for loop. And if we don't know necessarily exactly how many times we want to loop over something, like we want to loop over something so long as some condition is true, then we would probably use something more like a while loop. But in this case, we're going to use a simple for loop. And then Python is all about tabs, right? So in Java, we use curly brackets and white space doesn't matter. But Python, the tabbing, the indentation of every single line of code matters, because that's how the Python interpreter figures out kind of where all the code fits and what code belongs inside of what other code, like in the scope of this for loop, for instance. So once I enter this for loop, I need to tab over one time. And then what we're going to do here is what's actually called a nested for loop, because we're checking for prime numbers, right? And prime numbers are any number that's divisible by 1 in itself, right? So for every, let's say we're checking for prime, let's say we're checking the number 16 for prime. We have to divide it by all the numbers between 1 and 15, right? And if any of them, or besides 1, give us back an even number, then that number is not prime. right? So I'm just going to say for x, and x is just a variable, just like this num is a variable. Num will be the number 1, 2, 3, 4, all the way up to 100. And then I'm going to say for x in range 2, because we don't actually need to check the number 1, right? We know that every single number out there is divisible by 1. So we're not actually going to check, whether every number is divisible by 1. We're going to start at 2, and then we're going to say num. And basically, in the beginning, like that 1, 2, 3, that's going to be not really going to make that much sense, or it doesn't seem all that necessary. But let's say we're trying to check whether the number 20 is prime. So this is, let's say, and we're on the number 20 in this first loop. So num is equal to 20. So then we're going to say for x in range 2 to num. So that means we're going to check the number 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to num, which in this case is 20. And what we're going to do is simply check whether inside this for loop, whether this number is divisible by any other number between 2 and num. So the way that I do that is I'm just going to say if num, and I'm going to use an operator called the modulo or modulus operator, which is just the percentage symbol. And this is basically what the modulo operator does is it returns the remainder of the division of a given number. So let's say if I say 5 mod 2, and oftentimes we shorten modulo to mod. So if I say 5 mod 2, the result I'm going to get back is 1, right? Because 5 divided by 2 is 2.5, right? Because 2 will go into 5 twice and have a remainder of 1. Or if I say 10 mod 8, the result is going to be 2, right? If I say 10 mod 5, the result is going to be 0 because 10 is divisible by 5 evenly. So 5 goes into 10 evenly twice. So for instance, 10, anything that has that mods to 0 means that it was evenly divisible, right? 4 mod 2 is 0, 6 mod 3 is 0, 8 mod 4 is 0. 8 mod 3 is 2, right? Because 3 goes into 8 twice, up to 6, and then has a remainder of 2. And so what we can say is that if a number is evenly divisible between, let's say, 2 and 20, in this case 5, when we hit 5 and 4, both 4 and 5 are going to mod into 20, and they're going to have no remainder. And that's going to mean that 20 is divisible by those numbers, which means 20 is not prime, right? So what we're going to say here is if num mod x equals 0, break, right? Because and all this is going to do is it's going to break us out of this loop, right? This loop right here. And because now we know that there was a number between 2 and whatever number that we're testing, in this case 20, that was evenly divisible, which means that this number is not prime, right? Else, if we get all the way through this for loop and it never breaks, right? This is a keyword, to break out of this loop. And code runs from top to bottom, right? So if we get down to this else statement, that means it went all the way through that for loop without ever hitting that break. And so the number that we are testing is prime because it was not evenly divisible by any number between 2 and itself, basically. So then I'm just going to print my num. So now I just hit escape to get out of insert mode. I'm going to type :WQ, and which writes and quits the file. And now if I do a little ls-al here, it'll list all the things in this directory. You can see that I've got this prime.py file. And if I run it, so if I say python3 prime.py, now it just printed out every prime number between 1 and 100. Great. So we've just run our first Python application, a very simple application that we ran through the command line. Something I always like helping people get comfortable with when they're first starting software development is that software development seems so complicated and kind of overwhelming and intense, but it's actually quite simple. Sure, the keywords and exactly how that worked in there take a little bit of getting used to, but all you really need is a text editor and a command line and the language of your choice installed. You don't need any fancy IDEs or super fancy software technology. You can be running on a $200 Dell laptop from 2008, and you can be a very, very productive software developer. Sure, having the nice modern stuff is useful and helpful, but software development is really just writing text and then executing that text using either the Java virtual machine or the Python interpreter. So I'm going to kind of bounce back and forth here, but I'm going to now go write a Java application, and I'll start the Java application in the IDE. So now I'm in IntelliJ, and I'll kind of come back to this, but in our classes, both our online classes and our in-person courses, we have all kinds of labs that we do for every single concept that we're working through. So for instance, just as a quick kind of peek, this is the labs project for our online Java course. And so for instance, let's say you're going through the arrays section of our online course. At the end of that, each section, it'll direct you over to the project that we cloned from GitHub and opened up in IntelliJ or PyCharm or VSCode, whatever IDE you're using. And it'll ask you to complete all the labs in that section. And there'll also be a bunch of examples of the concepts that we've talked about. So for instance, same thing, conditions and loops. There's a bunch of labs that you're asked to complete, like using a for loop, print out all even numbers between 1 and 100. And then there'll also be all kinds of examples that show you this kind of stuff in action, right? So for our case, though, we are going to create a new simple little project. I'll just say Java 1.8, next. I'm going to call this webinar Java IntelliJ. I'll say new window. Cool. So now I've got an empty project here. And in Java, all of our code always goes in the source folder, the SRC folder. So what I'm going to do here is I'm going to create a new package, and I'm just going to call it Java. And then in Java, I'm going to create another new package. It's kind of standard, and it's going to just be called examples. I'm going to refactor that. And then here in this java.examples package, I'm going to create a new Java class, and we'll call it prime. And because we're working in the Java IDE, I don't need to say like .java, and just like we did prime.py. In Java, it'll be prime.java, but the IDE just handles that for me. So now we're in a Java file, which is a little bit slightly different. The syntax is a little bit different. You'll see lots of semicolons and lots of curly braces, which are not present in Python. But what I'm going to do is I'm going to create a simple main method. The main method is where all Java applications start. And the nice thing about using an IDE like IntelliJ is there's all these shortcuts. So I can say PSVM, for instance, and that's a little shortcut to create this main method. The main method, when the JVM starts a Java application, it will always look for the main method, which is the entry point for all Java applications, unless you specify otherwise, which you can, but it's not really necessary. So the main method is basically considered the front door or the entry point to every Java application. This just means that it's publicly available. Static means that it's not related to any object. Void means that it does not return anything. Main is the name of the method. And then these are the parameters that this method takes. In this case, it's string array args. These square brackets mean array. And that's because these string array args, when we run this Java file from the command line, we can pass in arguments. And they would be captured here in this variable called args. So we're going to do the same thing here where we just determine prime numbers. So, and I'll kind of have a little fun with this. And I'll say print primes. And I'm going to make this a new function or a new method. And if I just type the name of the new method that I want, and I put my cursor in it and I hit Alt-Enter, I can just say create method right there, print primes. If I wanted to, just to kind of demonstrate as a side, I could say, let's say x equals multiply 2, right? Or int x equals. So in Java, it's strongly typed, which means that we have to declare the data type of every variable we're using. And this is a method that I'm not using yet, but I'm going to go ahead and create it. I'm just going to demonstrate this to you. So this is slightly different. See, it's private right now because this is a method. We can change this, but it's a method that's only going to be used within this class. Again, it's static, which is a more complex kind of concept, which I won't really go too deep into. It just means that it's not related to any specific object of this class. Int is the return type. So that means that this method returns an int, right? Int multiply is the name of the method. And then int I and int I1, or we could just say int A, int B. These are the two parameters or arguments that are going to be passed into this. So then I can simply say return A times B. And so this is a simple method, just a simple multiply method that now, rather than ever, and this is a very simple example, but rather than ever have to write a multiplication ever again of two numbers, if I have this multiply method anywhere in my application, I can just call it. And then here I could say system.out.println x, for instance. And I'm just going to comment this out for a second. And if I right click on this and say run, it's compiling. Prohibited package name. So here we can see that the number 4 printed, right? And this is just a little, the only reason I'm kind of saying this is to get you, just to kind of give you a preview of the way that methods and functions work. So here I'm calling the method called multiply. I'm passing in 2 and 2. And what gets returned from this multiply method is an int, and that int gets assigned to the variable x right here. And then I'm just printing out that variable. So that's just a little quick aside. I'm actually going to just delete that stuff now. And we're going to go back to printing primes. So we're going to basically do the same exact thing in print primes, where I'm going to say, we're going to get a random number. So I'm going to say int num equals, I think I need to create an object here, random. And this is just random is a package that's part of the Java library. It's in java.util.random. It's a class. We can actually go look at it by holding command and clicking on it. Now, this is a class that's actually written in the Java language, right? And so I can go look at this code, but basically what it allows us to do is just get random numbers, right? So here I create an object of this random class called random, and here I'm just gonna say int num equals random dot next int. And if I go look at next int, I can probably give it I can give it a bound. So bound would be the upper bound exclusive must be positive. So if I wanted to make sure that my random number is between a certain range, right? Then here I'll say next int 100. So that'll give us a random integer between 0 and 100. Then we're going to do basically the same thing. So I'm going to say for int I equals 0. So we're going to start at 0. Or I guess we could start at 1. And then while I is less than num and I++. So this is a for loop in Java. So basically what I'm doing here is I'm initializing basically our counter. Then this is a Boolean condition. So while I is less than num, we'll continue looping. And then on each loop, we'll increment I by 1, right? Again, we're going to do a nested loop here. Or I guess rather than, do we need a random number here? We don't. I'm going to take that back. I'm going to say while I is less than 100. So we're just going to check for every prime number. I was getting ahead of myself because the next lab that we're going to do, or example that we're going to do, is going to be kind of a guess my number game, where we do pick random numbers. So just got ahead of myself there. What we're going to do is test all the numbers between 1 and 100 for primes. So here I'm going to write another for loop. And this one is going to say int x equals 2, again, because we don't need to test any number whether or not it's divisible by 1. We know that all numbers are divisible by 1. And then I'm going to say while x is less than I, and then x++. And in Java here, this is called scope, right? So you'll see these curly brackets, like when I click on this one, this is yellow and this is yellow. This is the scope of this method. If I click right here, you can see that this is yellow and this is yellow. This is the scope of this for loop. If I click on right here, these two light up. This is the scope of this inner for loop. In Python, this is all handled by tabs and indentation. In Java, we handle scope by opening and closing curly brackets, right? So like this entire for loop is inside the scope of this for loop, right? So for every loop of this outer loop, this inner loop will loop like as many times as it needs to exit that loop, and then it'll exit this inner loop and go back out to the outer loop, right? So it'll start at I equals 1, and then go in here in the for loop, and then it'll come back out I equals 2, I equals 3. Enough sound effects, but hopefully you get it. And here it's x++. So what we're going to basically do is we're going to go from 1 to 100. And for each one of those, we're going to test whether that number is divisible by any number between 2 and itself, basically. I will be, in this case, we were using 20 in that Python program. So let's say I is 20. It will test whether any number between 2 and 20 divides equally into 20, in which case that is not prime. So same thing, I'm going to use the modulus operator here. So I'm going to say if I mod x equal 0, break. And in Java here, we'll use a semicolon when we have executable lines of code. They're all ended by semicolons. If we get all the way through that for loop and we never hit that break statement, the break statement would just break out of this for loop, right? If we get all the way through this for loop without ever having to break, then we will we know that the number is prime. So let me double check this here. You know what I could also do is I'll have I'm going to use a little Boolean. So I'm going to say is prime equal true. So I'm going to assume that the number that I'm working with is prime. So a Boolean is just a data type that can either be true or false. Its name is prime, and I'm setting it to true. And here, if I mod x equal 0, so basically meaning if the number 20 mod, let's say x is 5, 20 divided by 5, the remainder will be 0, which means that it is evenly divisible, which means that it is not prime. So here I'm just going to say is prime equal false, and then break. So that'll break me out of this inner for loop. And then I'm going to just say if is prime, sout, what is it, I, right? So is prime is that Boolean. So I'm going to say if it's still true. So if we got all the way through this for loop without is prime ever being set to false, and I could also say equal true, if is prime equal true. But in Java, you don't actually have to do that. You can just say if is prime is true. It'll work like this. Then I'm going to print out that number. Otherwise, just continue looping. And that should just about do it. So let's see if this works. Yep, it worked. So here we printed out all the prime numbers between 1 and 100. We did it in Python first. Oops. And so you can see how Python is a bit more, or a bit less verbose, a little bit more intuitive potentially. So we've got 1, 2, 3, 4, 5, 6 lines of code here, whereas in Java we've got quite a bit more. And I added a couple of methods here just to kind of show you a little bit how things work. The way that this works is when this main method gets called, all this main method does is it calls this other method called print primes. So this is what's called a method call right here, which will jump us down into this method where it does all the work. And this is the way programming languages work, right? We put all of our code in functions and methods, and then we just call those functions and methods to do what we need to do, right? So like for instance, all the methods in a math class, multiply, divide, subtract, addition, sign, all the other things, those will just be simple methods that we can call as many times as we need to do that work, right? There's no need. One of the primary rules in software development is called DRY, dry, which stands for don't repeat yourself, right? You should never write the same line or lines of code twice. So if there's ever something that you need to do more than once, like let's say in my application, for some reason I need to find the prime numbers in more than one location, I should just write a method that does that, and then I can call that method from whatever location I need to find primes from, right? And now I can say, give me all the prime numbers under 500. So here, instead of 100, I would just say hi. So these are all the prime numbers between 1 and 500. So we're coming up on the 1 hour mark, so I'm going to jump over into the Git process real quick, just so that you guys have that. And then I will continue on with 2 other fun little applications, guess my number games. But just to keep it within the 1 hour with the stated goals. What I'm going to do here is I'll just copy this Java code into a text file here from the command line, so I can show you how to run this Java code from the command line as well. So I'm going to say vim prime, make this a little bigger and clear it up. Let's say vim prime.java. Hit I for insert. I'm going to paste in all this code that I just wrote in Java. :WQ to write it. And now if I do ls-al, ls is just the command to list anything in this directory. So here when I say ls, now I can see prime.java, prime.py. I always like to do the ls-al because it gives me a little more information about what kind of file it is, who owns it, how big it is, when it was created, the time it was last modified, etc. So to run a Java application from the command line is a little bit different because we have to compile it first. So what we have to say is javac, javac, which is the Java compiler, prime.java. Should be a class called prime. What is it? Oh, I need to capitalize it. So Java is, again, a very strict language. So because my class is prime with a capital P, and I did not save it as a file called prime with a capital P.java, it didn't like it. So I'm going to rename it. So I'm going to move prime.java to prime.java, which is just the way that you rename things on the command line. So now that should work. So javac. So now after I compiled it using the javac command, the Java compiler command, now you can see that we've got a new file in here called prime.class. And the class file is actually the bytecode that the compiler generated that the JVM will execute on the Java virtual machine will execute basically on the CPU. We can vim this prime.class, and typically it's nothing human readable, right? So there's just a bunch of junk in here. It's not meant for our eyes, right? But then now to run that Java class, I'm just going to type Java and then prime. I can type class because what we actually execute in Java is the class file, not the Java file. Java gets compiled into class files, and that's what runs. And since the Java command only works on class files, I don't actually need to say prime.class. I can just say Java prime. Could not load main class prime. Let's see what we got here. Oh, the package. In this case, there we go. So this just printed out all the prime numbers between 0 and 500, which is what our Java application does. The little issue that I had there was that in my IntelliJ application, I put it in a package. So I had, just delete this. I had this package webinar.examples. And so you can see that all of this code is in a package. And typically, even whether we're writing Python or Java, when we're writing larger applications, we put everything in packages, which is basically just like folders and directories to keep all of our code nice and organized. But when I'm running it from the command line right there, to get that to work, just so you know, I will, like I can show you webinar examples. So I would have to say make dir webinar, cd webinar, make dir examples, cd examples, vim prime.java. And the JVM, when it goes to run this application, it's going to, strangely, the packages just correspond to directory structure. So that's going to run. Now to actually run this, because I have this package webinar.examples, and this is not really the way we do it out in the real world, but just to explain that little problem we just had. Now I have to go up here to where I can see the webinar package, and then I would say Java webinar/examples/prime. And now it'll work. This could make a little more sense. I'm happy to explain it more one-on-one anytime. But basically, the Java virtual machine, when a code is in a package that actually corresponds to the directory structure that's in. So I had to go create that webinar folder, and then inside that webinar folder, I had to create that examples folder, and then inside that examples folder, I had to create that that prime class. That being said, I'm just going to remove that from now. So I am going to rm this prime.class, because we never push class files to GitHub because they're compilable. They get regenerated every time we compile a file. So it's not necessary to push those to GitHub. And I'm also going to remove recursively this webinar folder because I'm not going to push that up to GitHub. So what we're going to do now is create a Git repository right here on our machine. So again, we're just going to check that we have Git installed. So I'm going to say git -- version. Cool, I've got Git installed. Clean this up. Then I'm just going to type git init. And so you can say it says initialize empty Git repository. And so now when I list everything out, you can see that there's this .git folder here. I can see that it's a folder here because this D means directory. Inside that .git folder is, you never have to touch anything in it. Git tracks every single change to every single character or byte, anything now in this repository. You want to be careful where you create Git repositories. I've seen many people before create Git repositories of their entire computer and then push their entire computer up to a public repository on GitHub, which is not what you want to do, right? Like, so if you go onto your desktop or your home directory and you say git init, you'll be creating a Git repository of your entire computer, which is not what you want to do. You always want to create Git repositories in small, finite places, like in this case, in this directory that we're in right here, this webinar directory. I'm going to create a Git. I've just created a Git repository just of this. And so if I say git status, I'm on the master branch. I've not made any commits, and I've got some untracked files. And it says use git add to include this and what will be committed. So I'm going to say git add prime.java and git add prime.py. And then I'm going to say git commit. So now if I say git status again, actually, you'll see that still no commits, but that changes to be committed are these two files. The way Git works is that it has what's called a staging area, right? So you can add files into the staging area, and then you commit all of those files that you from the staging area into a single commit. And a single commit is basically a time in history that you can revert back to at any time, which is really nice. And we don't want to have a commit for every single file that we've modified, because when we're working, it's very, very common that we'll modify 15, 20 files to like change a single functionality. And we don't want to have a commit for every single one of those. We want to add those all into the staging area and make a single commit. And with that single commit, you can say like fixed emailing functionality or whatever. So so what I've just done with adding these two files is I've added them to the staging area. And then now I'm going to commit these two files and I'm going to give it a message. So git commit -m. And I'm going to say first push first commit webinar. So now two files were created, prime.py. Now if I say git status, on branch master, nothing to commit, working tree clean. So now just so you guys know, let's say that I go into vim prime.java, and let's just say I change one thing. Like let's just say I add a space there. And now if I say git status, that file will have been modified. So if I want to catch that modification and I want to track that in Git, I have to say git add prime.java, and then I'll have to commit that as well, and with a message demonstrating git difference /add. So you don't need to use GitHub or any kind of third-party repository, right? Git you can work with it entirely on a computer, just like I've done here, and I can just leave it this way forever, right? Git is just an application that runs on our own computer to track every single change that happens inside that directory. That being said, as soon as we want to start working with other people and we want to start collaborating, or I want to share my work with somebody else, or we're all working on one large project, which is always the case on the software development team, engineering team, we use a shared repository. And the most common shared repository that we use is called GitHub, which you guys have all probably heard of. And the way that we now get this code from my computer onto GitHub is quite simple, and we'll go through it right now. So I'm just going to go to github.com/CodingNomads. And I'm going to hit this little plus button up here in the top right. I'm going to say new repository. And we're going to call this Java Python webinar. And I'm going to leave this as public. And I'm not going to initialize this with a README quite yet. And I'm going to say create repository. And now Git is great because it always kind of tells you what you need to do or what you might want to do, right? So if we have a new repository, we would follow these instructions, or if we have an existing repository, we'll follow these instructions. We do have an existing repository because we ran git init, right? And over here on our command line, we can see like this is an existing repository. So what we need to do here is say git remote add origin, and then this URL. And all this does is git is the command to say I want to work with git. Remote just means I'm like we're dealing with remote git now, like something like GitHub, and I want to add a remote. I'm going to call it origin, and this is the link to that remote repository. So now if I take git remote -v, for instance, you can see and it has fetch and push, but you don't really need to worry about the two. But you can see that we've got this remote hooked up, and it's called origin. So now here I can just say git push origin master. Looks like it worked. So now if I go over here and I refresh the page, there it is, prime.java and prime.py. So I will create a small README. So there's a nice make a README website here. And we're just going to say, and I only show you this because I think READMEs are really, really important. And this make a README website is really nice because READMEs use a certain kind of markup syntax where we type it like this, but it looks like this. After the webinar is over, I'll come up through and finish this README. But for right now, I'll just go in here into Vim or back over to our project. I'll say Vim readme.md. And this is a standard all Git projects typically have one, or they should. I'll just put this in here. I'm going to add it. I'm going to commit it. And then I'm going to push it. Great. So now if I come back over here to our repository, the README gets automatically displayed right here. And so it's nice. I'll have basically a couple of links, for instance, for the installation instructions and a couple of other things, and just a little, I'll probably have a link to this video when we host it up on YouTube, etc. READMEs are really valuable and important, and no good professional project does not have a README. So as you're getting started pushing your projects to GitHub, always add a README. And this make a README website is quite nice because it kind of has all this default text here and kind of the various different markup that you use, a single hashtag, a double hashtag. If you want a little code block, three backticks above and below, how to make a link right here, square brackets. So you obviously come through and change all this, but it's just a very quick way to make a nice, useful README. And a README normally has things like what this application does, how to install this application, or things that you might need to install to run this application, how to, maybe the technologies that are used in this application, maybe the various collaborators, whether they be people or organizations, the license, is this publicly available to use, etc. So always adding a README to your applications like GitHub is a really nice thing. Okay, great. So I'm going to run one more application in Java and Python. And so what, we got a chat. Yeah, you're welcome, Mohammed. Thank you for joining. All right, so I'm going to say new file. And we're just going to write a very simple Python application that is like, it's called guess my number, right? So the computer is going to have a number, and it's going to be, the user needs to guess that number. The first thing that we're going to need to do is we're going to need to import, and now I'm using the VSCode IDE. So this is a very, very useful IDE for a number of different programming languages that's getting more and more popular. For Python, I go back and forth now between VSCode and PyCharm. PyCharm is made by JetBrains. It's the same company that makes IntelliJ, which is my favorite Java IDE. IDEs are integrated development environments, and they just make our lives a lot easier because they have things like autocomplete, and they'll show us where our syntax errors are, and they're just useful, and they make us more productive, right? So we can write all of our code through a text file if we want to, but you're going to be much more productive if you use an IDE almost all the time, right? So this is inside the VSCode IDE, and the first thing I'm going to do here is I'm going to say import random. And then I'm going to say num equal random dot rand int. In this case, we're just going to have between 1 and 10. And then there's going to be a guess, which I'm just going to set to none. And then I'm going to say while guess does not equal num, we're going to get an input from the user. So guess equals input. And then I'm going to tell the user, guess a number between 1 and 10. And then we'll say guess equals int, make sure it's an int guess. Then we'll say if guess equal num, then, oh, I'm going back and forth between Java. It takes me a minute to get my syntaxes right. I'm going to say if guess equal num, meaning if the user guessed the right number, I'm going to print out, and I'm going to do a formatted print. So I'm going to say F, congratulations, you won. And then I'm going to say the number that they guessed, or let's just say num, was the winner. Else if, or elif in Python, guess, the user's guess is greater than num, then I'm going to say printf, nope, sorry, guess is too high. Say else if, elif in Python, guess is less than num. I'm going to print, oops, nope, sorry, guess is too low. And that should just about do it. So I need to save this as guess.py. And now I can run it. So it's telling me to guess a number between 1 and 10. I'm going to guess 5. Nope, sorry, 5 is too low. So I should have a little colon here and a space. I'm going to quit that and clear it. Run it again. Guess number between 1 and 10. I'm going to guess 5. 5 is too low. I'll guess 8. 8 is too high. 6. Too low. 7. Congratulations, we won. And I can run it again. Guess number between 1 and 10. I'll start with 5. Too low. Go with 8. Too low. 9. 9 was the winner. So very simple how to build a guess my number game in Python. And now we can really quickly go do that same exact thing over in Java. So I'm going to have a new class called guess my number. Again, we need that main method. And I'm just going to do everything here in the main method. So I'm going to say random. And I'm going to call this object random equals new random. And I'm going to give it the upper bound of 10. Then, or wait, so I don't want to seed. Let me get the 10. I actually get the number. So I'm going to say num equals random. Back in Java now, I've got to say my data types. Random.next int. And I'm going to give an upper bound of 10. So then I'm going to ask the user for some input. So I'm going to say, first I'm going to print out something. Please enter a number between 1 and 10. And then I'm going to take in what they enter. So I'm going to say scanner equals new scanner. And this is going to be system.in, which is just the command line. This is a package I need to import. So I'll put my cursor in here and say Alt Enter, and I'll import this class. And now we can see that I've got these 2 imports. And this is just an example of using code that other people wrote. In this case, the people that wrote Java wrote this. But the amount of Java libraries and Python libraries out there that were not written by the Java people or the Python people drastically outweighs or outnumbers the amount of stuff that's actually written in the Java or Python libraries, right? The Java and Python libraries might have a couple hundred classes and packages for you to use, and there's millions of classes and packages for you to use in Java and Python that are generally available out there on the internet. So then I'll say int guess equals scanner.next int, and I'll say we'll make this a looping game. So we'll say Boolean continue playing equal true, and we'll say while continue playing. We'll put all this inside a while loop actually. So here's an example of an indefinite iteration. I don't know how long we're going to want to loop, so I'm going to use a while loop. And then I'll say, we can make another Boolean. So I can say while not correct guess. Well, there's a few ways that we can do this here, but if guess equal num, sout, you win. And I could say plus guess plus was the right number. Else if guess is greater than num, nope, sorry, plus guess is too high. And then lastly, if guess is less than num, nope, sorry, plus guess plus is too low. And here I will turn continue playing to false. So it'll stop looping. And so here we can say, for instance, welcome to guess my number. And then we could say, okay, I've got a number in mind. Now when I run this, we can run it right here in this IDE. It says, okay, welcome to guess my number. Okay, I've got a number in mind. Please enter a number between 1 and 10. I'm going to enter 5. Nope, sorry, 5 is too high. How about 3? Nope, sorry, 3 is too high. Too low. I win. 2 was right. There we go. So now I'm going to very quickly, I'll go add both of these files into our GitHub repository. So I'm going to say vim guess, and I'll just call it guess.java. We've got these 2 new files. So I'm going to say git add guess.java and git add guess.py. Git commit -m, adding guess my number things. And then I'm going to push that. I'm going to push it up to the remote that's called origin and to the branch that's called master. Boom. All done. So now if we go over here back to this repository on GitHub, we'll be able to see that we've got the guess, the prime in both Java and Python, as well as the README, which I will go ahead and expand after the webinar. The last thing I'd like to kind of mention to you all and just give you a little preview is CodingNomads Online Learning platform. So we've got, at the moment, 6 courses. We've got another 4 courses in development, but we've got courses in Python, software development, data science and machine learning, APIs and databases with Python, SQL and databases, Java software development, and they're quite intensive and comprehensive. So these are courses for people that do not want to just learn a little bit, just do 2 or 3 tutorials and just get to step 1 or 2, maybe step 3 or 4. These are very comprehensive online courses that have all kinds of documentation to be read, videos to be, custom videos to be watched, coding challenges, games, journaling, mentorship, one-on-one mentorship, super comprehensive online courses that we've been developing over the past year or so. Basically, we've been taking all the curriculum that we taught in our online, or sorry, in our in-person courses over the last several years, and we've been turning that into online curriculum. And it includes, literally hundreds and hundreds of pages of documentation. I think it's over 300 videos, several hundred labs and challenge coding exercises, and access to our members-only forum, and depending on what you might be interested signing up for with a one-on-one mentor, which adds you also to our Slack organization. So we've been spending a lot of time over the last 12 months building out this online platform, and it's quite comprehensive in our courses for both Java and Python. And as I mentioned, we're also building more courses like Python for Finance and the JavaScript course, and we're currently about halfway completed with our Data Science and Machine Learning course. And we put a lot of work and a lot of pride into these courses, and we found them to be very, very useful for many students that have already signed up. So if you're interested in learning more about Java and Python online, you can go to platform.codingnomads.co to come take a look at this, and you can create your own account. Half of the courses that we have on here are free. The other half have got extended free previews. And if you're interested in coming to one of our in-person intensives, you can just go to our CodingNomads.co website. Our next in-person intensive will be in Bali. The in-person section starts in the beginning of March 2nd. That being said, all of our in-person courses have a 2-month online prep course requirement, which is completed with a mentor on our online learning platform. So for instance, for this upcoming Java course that starts in Bali on March 2nd, basically you'll be needing to work on the online prep for by early January to be in the right position, because basically we want everyone to arrive to our in-person courses basically already knowing core Java, so that once we get in person, we can immediately start diving into the more complex, modern style software that people are using at day-to-day, at the enterprise level at work. So as mentioned, we've got 500 plus pages of documentation and tutorials, 300 plus fully functional code samples and exercises, 150 plus video tutorials. These are for each course. So we've got this for Python and this for Java and several other courses that are in development. It gives you lifetime access to this material and to our members only forum when you do sign up for any of our online courses. We've had many, many students come through our programs. We have 100% 5-star reviews on SwitchUp and Course Report. But you can kind of go see for yourself on SwitchUp and Course Report what other people say. Graduates of our program have become startup founders, product owners, junior developers, and promoted in their current careers. And on our website, you can see a number of companies where our graduates work, but KPMG, Marketo, Experian, Philips, Enterprise Engineering. There's a whole bunch of them. What is this? Adobe, Yale, Zoot, Salesforce, Experian, the University of Texas, Lockheed Martin. If you're looking to learn Java or Python, we can absolutely help you. If you'd like to join one of our in-person courses, please let us know soon, because the enrollment deadline is approaching. And if you'd like to join one of our online courses, feel free to just go to the platform, create your own free account, and start poking around. And you can always feel free to reach out to me directly, Ryan@CodingNomads.co. It's been a pleasure to chat with you all today, and I hope that you have found value in this webinar. And please feel free to reach out anytime, and have a great day.
It's been 14 days since Java was terminated. Society has completely collapsed.